Welcome to Homework Lib.
Hi, so for this question we need to, first of all, remember that the logarithm in the pH is with base 10. So that means that the concentration of H3O plus that you're dealing with, it is going to be equal to 10 to the minus pH. So 10 to the minus 3.72. Okay, so this corresponds to a concentration of 1.91 times 10 to the minus 4 molar. Next up, we need to propagate the uncertainty. The way to do that is we need to look up on different tables on what is the propagation of the uncertainty for selected mathematical functions. So, for example, if your function is r times a constant times a variable, the uncertainty on r, it is going to be k times the uncertainty of a directly. Okay. If we have sums, we have the sum of the squares, and if we have multiplications, we have the values for relative uncertainties. In this case, our function r, let's say that this r is the concentration of H2O plus. Remember that this is an exponential. So this is 10 to the value of the pH. For functions like this, of the shape r equal 10 to the a, the way to calculate uncertainty is that the uncertainty of r, or the absolute standard deviation that we are going to get, both of them are equivalents, one with the other, is going to be provided by the following equation: 2.303 times the uncertainty of A. What this is going to look like for us is the uncertainty of R is the value that we want to get. This is the answer to our problem, divided by the value for concentration, the one that we just found, 1.91 times 10 to the minus 4 molar, is going to be equal to 2.303 times the uncertainty on the pH, and that value is 0.03. Okay? So this is called propagation of uncertainty. Let's get rid of the equations that we're not using anymore. So let's get rid of this part, and we're left with this. So now the uncertainty on my concentration, I'm going to write it down instead of R, this was concentration of H2O plus, will be equal to 2.303 times 0.03 times 1.91 times 10 to the minus 4 molar. And the result for this uncertainty is equal to 1.3 times 10 to the minus 5 to the minus 5 molar. That is the absolute standard deviation. Now, how do I report the result of concentration of H2 plus? This would be my result reported in the significant figures that I have. So it would be 1.9 times 10 to the minus 4 plus minus 0.1 times 10 to the minus 4, and all of this in molarity. And this would be your final answer. Thanks.